Let us look at some more quadrature. Let's say we have y square is equal to x. Now the curve looks like this. Now we have to find the area bounded by y is equal to 1, y is equal to 2, y-axis and the curve. So this is y equal to 2 and this is y equal to 1, and you have the y-axis and the curve. So we have to find the area enclosed by these boundaries. We take it as x equal to y square. Then the area is equal to the integral from 1 to 2 of y square dy. We know the integral a is equal to y cube by 3 from 1 to 2. Substituting the limits, we get area is equal to 2 cube by 3 minus 1 to the power of 3 by 3, which is equal to 8 by 3 minus 1 by 3, which is equal to 7 by 3. Now let's look at the area of a circle centered at h comma k. So let's say we have this circle which is centered at h comma k. So it is not at the origin. Now we know the area of a circle which is not centered at the origin. It is x minus h square plus y minus k square is equal to r square, where r is the radius of the circle centered at h comma k. Let's rearrange the terms. Y minus k square is equal to r square minus x minus h square. Taking the square root on both sides, we get y minus k is equal to plus or minus square root of r square minus x minus h square. So here, the plus sign would be applicable for the top half circle. That is a semicircle on the top side. And the negative sign will be applicable for the bottom semicircle. Y is equal to this k, we take it to the other side. We get k plus or minus square root of r square minus x minus h square. So the area of the circle is equal to 4 times the area bounded by y is equal to k plus square root of r square minus x minus h square, y is equal to k, x equal to h, and x equal to r plus h. Now here, what does this mean? We have y is equal to k plus square root of r square minus x minus h square, which is the top semicircle. So that defines one boundary. Y is equal to k is the horizontal line passing through the center. X equal to h is the left boundary or the vertical line through the center. And x equal to r plus h is the right vertical boundary. So what this boils down to is these lines. So we have this line, the lines going, a horizontal line passing through the center, and we have the curve. So here we are talking of this particular area. Since it is symmetric across the horizontal line and across the vertical line passing through the center, we can just multiply it by 4 to get the area of the entire circle. Area is equal to 4 times the area bounded by this. So we have 4 times the integral of f of x minus g of x dx from h to r plus h, where f of x is equal to the top semicircle minus the g of x equal to k. So what does this mean? F of x minus g of x. See, we require the height of the function from this horizontal line. How do we get that? F of x will give us the height of the curve from the x-axis, whereas g of x will give us the height of the horizontal line from the x-axis. So when we subtract these two, we get this height. So A is equal to 4 times the integral from h to r plus h of k plus square root of r square minus x minus h square minus k dx. Now here k and k cancel out, and we have 4 times the integral of square root of r square minus x minus h square dx from h to r plus h. K and k have disappeared. Okay, now let's integrate using substitution. Let me get rid of this. So I say u is equal to x minus h. Then du is equal to dx. Now we have to change the limits. So if x equal to h, then u is equal to 0. If x equal to r plus h, we get u is equal to r. So after doing the substitutions, we end up with area is equal to 4 times the integral from 0 to r of square root of r square minus u square du. Now again we do substitution. So here we say let u equal to r sine theta. So du is equal to r cos theta d theta. Again changing the limits. When u is equal to 0, we will have r sine theta equal to 0. That means sine theta equal to 0. That means theta equal to 0. And when u is equal to r, we will have r sine theta equal to r cancels out. We are left with sine theta equal to 1. And we know in that case, theta is equal to pi by 2. After substituting, we have area is equal to 4 times the integral from 0 to pi by 2 of square root of r square minus the square of r sine theta. Du is r cos theta d theta. Now let's simplify this. We have here r square is common to both. So we take it out. We get r square times 1 minus sine square theta. Now r square and square root cancel out. So we can take out r square out of the square root. We get r, but there is already an r outside. So r times r is r square, which we take it out of the integral. So we have r square times the integral from 0 to pi by 2 of square root of 1 minus sine square theta times cos theta d theta. Now 1 minus sine square theta is cos square theta, and square root of cos square theta is cos theta. And we have a cos theta here. So we end up with 4r square times the integral from 0 to pi by 2 of cos square theta d theta. Okay, now cos square theta is equal to 1 plus cos 2 theta by 2. That 2 in the denominator, we take it out of the integral. We end up with 4 by 2 r square times the integral 0 to pi by 2 of 1 plus cos 2 theta d theta. 2 and 4. After cancellation, we are left with 2r square times the integral, and we split these terms. Split this integral. Integral from 0 to pi by 2 of 1 d theta plus 2r square times the integral from 0 to pi by 2 of cos 2 theta d theta. Actually integrating it, we get 2r square times theta from 0 to pi by 2 plus 2r square times integrating cos 2 theta, we get 1 by 2 times sine 2 theta from 0 to pi by 2. Taking care of the limits, we get 2r square, which is common, times pi by 2 minus 0 plus 2 and 2 cancels out, r square times sine 2 pi by 2, that is sine pi, minus sine 0. Simplifying it, we get 2r square times pi by 2, that is pi r square, plus sine pi is 0, sine 0 is 0. So second term totally disappears. And we are left with A is equal to pi r square, which we know is the area of the circle. That was quadrature. If you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.